formula established for the left and right Riemann sums, let's actually put those formulas into practice with the following example. So we're back to the function f of x equals x squared, drawn over the interval from 0 to 2. Estimate the area under the graph using a right Riemann sum with 10 rectangles. Now, the first thing that I want to do is I want to compare this particular setup with the general setup that we were dealing with in the previous example. In the previous example with our formula, we were dealing with the graph as drawn over the interval from a to b. Here, we're dealing with the interval from 0 to 2. So I'll start by making a note that the first number in my interval, the left border, is 0, and the right border is 2. Now, I remember as well from the formula that we overviewed previously that the letter lowercase n was being used to represent the number of rectangles that we were using to tile the region. In our case, we are using 10 rectangles. So I'll make a note that our value of n is 10. So now let's consider what would be the width of each of these rectangles. What would be the change in the x value? The change in the x value would be the total width of the interval b minus a, 2 minus 0, divided by the number of rectangles that we have, in our case 10. So our value of delta x would be 1/5. Now, what about the height of the rectangle? Height of rectangle K. To get the height of rectangle K, we had the general formula that it was f, and we plugged in a plus delta x, in the case of the right Riemann sum, times k. For the left Riemann sum, times k minus 1. For the right Riemann sum, times k. Now, our value of delta x is 1/5. Our value of a is 0. So let's use that information. If we plug in a equals 0 and delta x equals 1/5, then we are really looking at f with 1/5 times k plugged in. And finally, using the fact that our f of x is x squared, then we can square 1/5 k and get a height of 1/25 k squared. So our goal is to take the area of each of these 10 rectangles, to take width times height for each of these 10 rectangles, and to add up the result. And this is the moment where those summation formulas that we developed the previous day really come in handy, because we have some shortcuts to help us to calculate this value. We have some shortcuts which say that this constant multiple can be pulled out in front, and you can just take the sum going from 1 to 10 of k squared. And we have the shortcut which says that that value can be found by plugging 10 into this formula, 10, 10 plus 1, 2 times 10 plus 1, all over 6. And boom, we have the approximation of the area under this curve between x equals 0 and x equals 2, using 10 rectangles. In our next example, we're going to see what happens if we let 10 just be a variable, and we let that number of rectangles grow larger and larger and take the limit as the number of rectangles goes to infinity.